Hello all. Today we will study single phase AC voltage regulator connected to RL load. What is AC voltage regulator? AC voltage regulator is a power converter which is used to convert a fixed voltage fixed frequency AC input supply to a variable voltage AC output. It is also called as AC voltage controller. For converting a fixed voltage to a variable voltage, the regulator uses power electronic devices such as thyristor or triac. The RMS value of the AC output voltage and the AC power flow to the load is controlled by varying the triggering angle or firing angle alpha of thyristor. Now, what are the various applications of AC voltage regulator? AC voltage regulator is used in motor drive system. It is used in electric furnaces, heat control. So we can say that it is used for industrial heating systems. It is also used in domestic heating systems. It is used in light dimmer circuit. It is used in HVAC system. It is also used in on-load tap changer of a transformer. So these are the various applications of AC voltage regulator. Now let us see circuit diagram of AC voltage regulator connected to RL load, and let us see how this particular regulator works. Now this figure shows a circuit diagram of AC voltage regulator connected to RL load. It consists of two thyristors which are connected in anti-parallel. So when a positive half cycle of a source voltage appears, thyristor T1 will conduct and connect load to the source. And when negative half cycle of a source will get applied to the regulator, then thyristor T2 will conduct and connect load to the source. So let us see how this circuit is operating. Here I have shown the input voltage waveform, triggering pulses applied to thyristor T1 and thyristor T2. The load current flowing through the load when voltage regulator will get turned on, and the voltage, output voltage appearing across the load. Now, when the AC voltage is connected to this regulator, then initially a positive half cycle of voltage will get appeared across the regulator. For this positive half cycle of a voltage, thyristor T1 will get forward bias and thyristor T2 it will start operating in a reverse bias condition. So we can say that T2 is operating like an open switch. Now, though thyristor T1 is operating in forward bias condition, but in the initial time period, no triggering pulse is applied to T1, and hence T1 is also operating like a open switch, and hence there will be no connection between the source and the load. At a firing angle alpha, triggering pulse is applied to T1, and with this T1 starts conducting, or we can say that T1 will get turned on, and with this the load will get connected to source through T1, and current starts flowing from source through T1 through RL load back towards the source. As the load consists of an inductor, so the nature of the current flowing through load is it starts gradually increasing towards the maximum value. And during this flow of current, energy gets stored in the inductor. At an instant pi, the source current Is it will get reduced to 0. The source voltage will also get reduced to 0, and after instant pi, the direction of source current and applied voltage will get reversed. But the load it is having inductor in it, and this inductor it opposes this change in the current which is supplied from the source. And in this particular operation, the inductor starts operating as a source, and it will maintain thyristor T1 in on condition, and whatever energy stored in the inductor, it will be supplied to the source from with the flow, such as the current starts flowing from inductor through source through T1 back towards the inductor. Now during this particular operation, the energy stored in the inductor will get released, and hence the current flowing through the load, it will get gradually decrease and it will get reduced to a magnitude 0. During this instant or during this operation from instant pi to angle beta, a reverse voltage across the load will get reversed, and a reverse voltage will get appeared across the load. Now at instant beta, the energy stored in the inductor will get completely dissipated, and at this particular time the current will get reduced to 0. Current flowing through this circuit will get reduced to 0. So a natural commutation takes place in T1, and T1 will get turned on. From instant beta up till instant pi plus alpha, though thyristor T2 is operating in forward bias condition, but no triggering pulse is applied to T2, and hence both T1 and T2 are operating like an open switch, and there will be no connection between the load and the source. At instant pi plus alpha, a triggering pulse is provided to T2, and with this T2 starts conducting, or T2 will get turned on, and the load will get connected to source through T2. Now the current starts flowing from source through load through T2 back towards the source. So with this, the direction of current through the load will get reversed, and the voltage appearing across the load will get reversed. So when T2 starts conducting, the current flowing through the load, as load is having inductor, so the current flowing through load will get increased gradually, and the direction of current is reverse. With this, a reverse voltage starts appearing across the load. At instant 2 pi, the source current and source voltage will get reduced to 0, and after this, the source current will change its direction, as well as the source voltage will also get reversed. But the load is having inductor, and this inductor opposes this change in the current, and it will try to maintain the flow of current in the same direction. And during this particular operation from instant 2 pi to 2 pi plus beta, the energy stored in the inductor will get released through the path inductor, resistor, T2, source back towards the inductor. So again the direction of current during this operation is reverse, but the current starts gradually decreasing, and at instant 2 pi plus beta, the current will get reduced to 0, and natural commutation will take place in T2, and T2 will get turned off. So during this particular operation from instant 2 pi plus beta, the voltage appearing across the load is positive. At instant 2 pi plus beta, both the devices T1 and T2 are in off condition, and from instant 2 pi plus beta to 2 pi plus alpha, no triggering pulse is applied to T1. So there will be no connection between the load and the source, and no voltage will appear across the load, or no current is flowing through the load. Again, at an instant 2 pi plus alpha, triggering pulse will be provided to T1, and the same operation will be repeated. So this is the working of single phase voltage regulator connected to RL load. Now let us see equation of a RMS value of a load voltage. The RMS value of a load voltage, it is given as square root of 2 into 1 upon 2 pi integration from alpha to beta Vm sine omega t square d omega t. So when we solve this equation, we'll get the equation as Vm square upon pi integration from alpha to beta 1 upon 2 into bracket 1 minus cos of 2 omega t d omega t. After simplifying or solving this equation, we'll get the final equation of RMS value of a load voltage as Vm into bracket 1 upon 2 pi into bracket beta minus alpha plus sine of 2 alpha upon 2 minus sine of 2 beta upon 2 raised to 1 half. So all these terms will be under square root. So this is the equation of RMS value of a load voltage for a AC voltage regulator which is providing power to the RL load. And this is all about the working of a single phase AC voltage regulator connected to RL load. Thank you.